Welcome back to our session. Today, I'll talk about two roles of territorial die and talk about discrete uniform law. So let's recall from our last example where we talked about two roles of territorial die. There, we had the grid. On x-axis, we had the first row. On y-axis, we had the second row. And, and as a sample space, we had x and y. Now, first thing is to now second step. That's the so we have our sample space, which is x, which is x and y. This is our sample space. Second step is to define the probability law. We'll use uniform probability law such that each of the 16 outcomes are equally likely, and we will assign that each 116 outcome is equal to 1 over 16. Now, third step is to calculate the probabilities. The probability we want to calculate is of x equal to 1. This is x. And we're going to calculate probability when x is equal to 1. Each of this scenario has probability of x 1 by 16. And under 4 circumstances when x can be equal to 1. Therefore, x equal to 1 can be calculated by multiplying 4 times 1 by 16, which is equal to 4 over 16, which is equal to 1 over 4. Hence, that's the answer for this question. Moving on to next question, where we want to calculate when z is equal to 4. Z is a function of minimum value of x and y. Now, for example, when x is equal to 2, and let's say y is equal to 3, z will be equal to 2. That's how it will work. Now, question says that what's the probability of z is equal to 4? This is only possible when x is equal to y is equal to 4. Because I say that because 4 here is the largest number, and it is saying that minimum value of this expression is largest number, so nothing can be less than 4. So both have to be equal to 4. Since there is only one scenario where this can occur, it will be 1 by 16. Moving on to next example, where we need to find the probability of z equal to 12 when this can happen. This can happen when minimum of 2 is is 2. Either x is greater or equal to 2 or y is greater or equal to 2. This can happen. Now, plotting this in diagram, x is greater or equal to 2. What does that mean? It means this. And y is greater or equal to 2. What we see here is that x is greater or equal to 2 or y is greater equal to 2. This is the event that I have drawn here. There are 5 possible outcomes there. Each one has probability of 1 over 16. If that's the case, then we can calculate the probability by multiplying 5 by 1 over 16. This is the answer to this problem. Moving on to the next slide, we'll now talk about discrete uniform law. The example we saw earlier was an example of discrete uniform law. To explain discrete uniform law, let's assume that we have a finite sample space and it has n elements. And these n elements are equally likely. Therefore, probability of omega is equal to n times 1 by n because each of them are equally likely. Now we'll take a subset of this sample space called A, event A, and this has a k elements. Now we already know that probability of each of these elements is 1 by n. Then we can calculate the probability of event A by multiplying k, the number of elements, by 1 by n, which will be equal to k by n. This is, from this equation, what we see is k is the number of elements inside event A, while n is the number of elements in whole sample space. What we are doing here is we are just counting number of elements inside the event A and number of elements in whole sample space. So therefore, counting is a really important skill we need to have. Now let me quickly summarize what we discussed today. We discussed about probability calculation for discrete and finite example using theoretical die, and we discussed about discrete uniform law. Thank you so much.